Dear students, now we are going to learn and going to demonstrate casting process, and the procedure will be shown in the next of this lecture. So, the first thing is that what is casting? Basically, this is an oldest manufacturing process, and in this process basically the material is first melted, then the molten material is poured into a previously prepared mold cavity, and after that it allows to solidify and cooling. Once it is solidified and cooling, it will be taken out from the mold cavity, and then the surface will be cleaned and machined. Now, as I have told or explained the procedure, now we have to understand the thing. Here in the casting process there are few important things, that is first your pattern, the tools, the mold cavity, and the melting temperature of the material. Now, in your daily life you may have been seen, or if you think that if we would like to make a candle, okay, so the candle is a circular shape, okay, so suppose we want to make a candle, so the candle is similar to this shape. So what will be done, we will take a circular hollow section, and in between that the molten wax will be poured. So when the molten wax will be solidified, it will be taken out. So this is how your casting process is done. Now, as I have told that the few important things is there, among which there is one important thing, that is your pattern. So what is pattern? The pattern is the replica of the desired shape. That means if we try to make a product, okay, so there will be a design, and that design will provide a particular shape and size, and in corresponding to that we will have to make a pattern which will be similar, almost similar to that our desired product. So suppose you can see I am holding a pattern in my hand. So when the final product will be produced, that will be similar to this. But before going to that, I will have to tell few things, that what are the advantages of this casting process. In this casting process we can make some complex shapes can be made. Second thing is that in this process we can use both ductile and brittle material. Third thing is that it is a less expensive process. Though there are some advantages, there are some limitation is also there. The limitation is that here in this process the product the surface of the product that will not be so smooth, there will be some rough surface, and that surface is needed to be cleaned and machined. Another thing is there, as there is the solidification and cooling process is involved. So if the entire section of the mold cavity is not uniformly solidified or cooled, there we may not achieve similar mechanical properties. So sometimes it may be needed that we may have to heat treat the casting product. Now we are going to each thing one by one. First thing I have told you, that pattern. It is the main one of the among the different important things. This is an important point, that pattern is okay. So among different things, one of the important thing in casting is pattern, and this is the replica of the desired shape. So before making pattern we have to keep few things on our mind, that while making pattern we will have to provide some allowance. Why these allowances are required? I will explain it now. There are different type of allowance which is provided to the pattern. Number one is your shrink. Different allowances are provided. The allowances are shrinkage allowance, machining allowance, draft allowance, distortion allowance, and ramming allowance. Now, among all these allowance, first thing is that your shrinkage allowance. As you know that when any liquid material, any liquidified material will be solidified, there will be some shrinkage. That means there will be the contraction in the entire volume. So, to compensate that, shrinkage allowance is provided. Second thing I have told you that your machining allowance, because there is an interaction between the product, that is your job, and the molding material. So, the surface will not be properly smooth. So, to provide the desired shape, to clean and to machine the surface, we will have to provide the machining allowance. Next is your draft allowance. After the solidification of the job, we will have to taken out it from the mold cavity. So, when it will be taken out, so we need to so that we can withdraw it from the mold cavity easily, there will be some draft will be provided. So, the surface of the pattern, if it is a plain surface, we will give some taper so that it can be withdrawn from the mold cavity easily. And there is also your distortion allowance and ramming allowance. Now, there are different types of pattern, that is your single pattern, split pattern, gated pattern, okay, partition pattern. So, different types of pattern is there. So, once the pattern is made, next it will be provided in the mold cavity. So, there are different mold material. Here we will use sand mold. Now, when the material mold cavity will be prepared, so there will be some certain properties which will help to improve the quality of the casting product. So, there are few properties which are mandatorily required in the molding sand. Now, among which I am explaining one by one. You can see there is refractoriness, that is the molding sand that will withstand the high temperature of the molten metal, that is the properties of the molding sand known as your refractoriness. Next important thing is the permeability. Permeability means the ability to escape the gases from the which will be the ability of the gas ability to escape the gases from the molten material, because when the material will be melted, some gases will be entrapped in between the your molten material. So, when it will be solidified, it is required to escape the gases from the molten metal, otherwise some defect will be found in the casting product and there will be some entrapment of the gases. There are other also there is your collapsibility, that means the mold will retain its shape when the casting operation will be performed. There is flowability is also required. So, these are the few properties which is required in the your molding sand. Now, to explain the casting process, here you can see that here this is a diagram. Now, basically here this can be said your mold cavity. So, the final product will be similar to this. Now, here when the mold cavity will be prepared, there is two part. The upper part is called cove and their lower part is called drag, and here this is your parting line. Now, through this pouring basin, the molten material will be poured, and Next it will come through this sprue and this is the runner, and through this the molten material will enter in this mold cavity. After that, here you can see this is the riser. So what is this? What is the function of this riser? I have already told you that the alloys which are provided to the pattern, there are different allowances. There was one allowance that is called your shrinkage allowance. So when this material will be solidified, so there will be the contraction in the volume. So to compensate that, the material, molten material will reserve here, and this shrinkage allowance that will be compensated from the riser. And when this solidification will process and solidification cooling procedure will be there, then at the last the material in the riser that will be solidified last. So this is how your casting process is done.
Now I am Professor Gautam Nandi. I will discuss about some tidbit of molding process as well as different casting processes. I think Professor Suman Nihar has already described the major parts of casting. So when the term casting is uttered, certainly it is related with some pattern. What is a pattern? Basically, it is a replica of the material which should be cast. Rather, we can tell it with the help of the pattern, we will make the mold cavity. Then, what is a pattern? How to make a pattern? And why different allowances has been given or provided into the pattern? That has also been described by Professor Nihar. So I want to show you initially some different types of pattern. So this is one pattern. This is known as reversing gear handle of a pattern. This is reversing gear handle of a lathe. The pattern is made by wood. So pattern material here it is wood. Second one is, that is Palmer block cap. Palmer block, the spelling is PLU, mind it. Palmer block cap. This is basically a complete gear. This is also one part of the gear. That means other part is also associated. That means it is not a single piece pattern. These three patterns which I have shown you, certainly it is a single piece pattern. This is another pattern. By seeing it, you will be able to understand what is the purpose of this pattern. It is nothing but the oval bracket. Oval bracket. Now I am going to show a typical thing. All these patterns are single piece pattern. You please see this pattern. Basically, it is the pattern of rope pulley. So we can divide it like this way. So it is two piece pattern, and this part or this part it should be located on the same position, and for solving the locating problem there is some dowel pin which will enter into this part, so that there should be no displacement among these two pattern. So this is known as two piece pattern. We have got another pattern, that is three piece pattern or multi piece pattern. So according to requirement, for the removal of the pattern from the mold, it may be single piece pattern, two piece pattern or multi piece pattern. What are the basic name of the different types of pattern? One is known as single piece pattern. Second one is two piece multi piece pattern. After that gated pattern. After that sweep pattern. So there are different types of pattern. We use it for our different purposes. Now the rest of the part about the different types of mold, different types of characteristics of the mold, strength of the mold, hardness of the mold, or the another different qualities of the mold has been discussed by Professor Nihar. So what is our target? Basically after casting we want sound mold. In engineering, sound mold means more or less that should be defect free. So what are the basic equipments required to prepare a mold cavity. First one, that is pattern through which we prepare the mold. Second one is, these four things are known as the locating peg, so that the drag part and the cope part, which has been written over here, one is drag part and cope part. For making the mold, this cope part is removed. After that, it should be replaced on the same place. To help it, this locating peg is required. This is known as rammer, through which we increase the compactness of the grain sand. This is known as, one is runner, another one is riser. Runner means through which the molten metal should enter into the mold cavity, through which sometimes it is known as sprue, through which molten metal will enter into the mold cavity. And another one is riser. The function of the riser, it will ensure that mold cavity has been totally filled up. After that, the excess metal will come over here, and during shrinkage, this molten metal will fill the shrinkage. So, this is riser is basically it is open in ambient condition. So, there is another riser which is known as blind riser, which is not exposed in ambient condition. What is the function of the blind riser? Due to any reason, if the molten metal present in this riser freezes, the blind riser which is present over here, which is not exposed in air, that will feed the metal during the shrinkage. For that only, as it is not exposed in ambient condition, it is under in between drag and cope, it is known as blind riser. And this is known as draw spike, through which we remove the pattern. We remove the pattern from the mold. This is known as basically cleaner. This is cleaner, this is also cleaner to clean the mold, and this is known as basically planer. And to improve for degassing system, so that the gas entrapped into the mold cavity, there are some processes through which we make some vent into the mold wall, which will be seen during practical training. This is known as vent holes. And another thing in this pattern, I think these four pieces, it is fitted with this pattern. It is fitted with this pattern. This projected part which has been fitted in the pattern, what is the function of this thing and what is the name of this thing? Basically, this is known as core print. Core print. What then the term comes, what is the function of the core? This is the core. Basically, this is the core and it is dry sand core. Now, you please think one thing, you want to make a hollow portion in the solidified material, but keeping it in mind, you are pouring the liquid molten metal, and now I am telling you have to create a hole within the material. How it is possible? So, it should be our target by applying something, whatever it may be, that is known as core, that will not going to allow molten metal into that part. If we do not allow to enter into the liquid metal into that part, certainly after the solidification of the melt, that will create a hollow surface. So, definition of core print, it is the added projection, it is the added projection, this is not a part of the pattern, rather this is the added projection is the pattern. Function of the core print is that to locate the position of the core as well as to hold the core, to locate the position of the core and to hold the core. So, this is all these four are core print, and this is the core. After molding, removing the cope from the drag part, this core will be inserted like this way, so that the molten metal will not enter into this zone. After solidification, when we will break the mold, that part should remain intact, keeping a hollow space within the casting. Now, Other major parts, I think it has been discussed by Professor Suman Nihar. Another part I have told you about the different types of casting. First, Suman Babu has described basic casting process, that is sand casting. Can you tell me what are the other kind of casting processes except green sand mold? After that it comes dry sand mold. After that it comes shell molding process. After that it is a die casting. But the difference between basic difference between die casting and green sand mold casting is that with the help of the die is made not by the sand, rather die is made by the metallic material, so that we can produce so many number of castings step one by one with the help of the die. No need to prepare mold every time. But the drawback of die casting is that it is applicable only for lower melting temperature of metals and alloys. After another thing, that is known as investment casting. After investment casting, that is gravity feeding die casting. After that slash casting, after that CO2 mold casting, and the hollow pipes are made by centrifugal casting. In the theoretical classes it should be, I think, discussed thoroughly. With this very little time is allowed to us, it is not possible to describe all these things practically. Now, the problem is that after the solidification of the melt, we get a cast part or solidified material. What are the conditions are required? First, the greens, if we take green sand mold, in most of the cases we prefer green sand mold, because the first point is that it is easy to mold as well as it is cheaper in the market. What material contents are there? Silica sand, bentonite, clay, water and some organic additives. With the help of these things we produce the green sand. After that, with the help of the pattern, drag part and cope part, we make the hollow cavity in which with the help of the runner riser we pour the liquid molten metal into the cavity. So, first thing is required, make the mold. After that, liquefy the material. After that, pour the liquefied material into the hollow cavity or mold. After that, allow for some time to reach the liquid molten metal into the room temperature. Break the mold, bring out the solidified material or the cast part, go for trimming. After that, we need for some machining. So, this is the more or less initial process. In accepting this thing, something should also be considered. What is the material used for making mold, what material we are pouring, what time is required, what should be the melting temperature of the material which we are pouring, and types of solidification, that plays an important role. And after completion of this process, it is our target, we want to produce some sound casting. What is sound casting? Basically, it is expected there should be no defect in the casting. Certainly, during different process, during different mold material, different molten material poured into the mold cavity, some defects may arise in the casting. So, what are the common defects? One is known as blowholes, another one is known as pinholes, another one is known as honeycombing, another defect is known as blister, another known as scab, another one is mold shrift, another one is known as core shrift, another one is misrun, another one is known as hot tear, cold tear, like there are so many defects may arise during the casting. But it should be our target, by combining so many methods, so many techniques, we want to get a sound casting, that is more or less defect-less casting. But how we should check? That is, after the cleaning, after the machining, we want to check it, whether it is sound casting or not. There are different testings. If the casting size is large, it is not possible to break it and check it. So, there is another different techniques are known as NDT test. The full form of NDT is non-destructive testing. But whatever may be the process, it may be machining, it may be casting, it may be forging, human eyes plays an important role. That is the best master to find out the defects, either machining, forging, casting, fitting, whatever it may be. So, go for visual inspection at first. Go for visual inspection at first. After visual inspection, if any defect we cannot find it out, then go for NDT or non-destructive testing. The first non-destructive testing is that pressure test. With the application of some pressure, it is basically used for checking the pressure vessel. After that, magnetic particle inspection. After that, magnetic particle inspection. After this, another authentic test is dye penetrant inspection. Dye penetrant inspection. If any crack which we cannot see through our naked eyes, with the help of the fluorescent dye, we can check it whether there is any crack just below the surface or not. Another crude technique is also there, that is sound, with the application of sound. You please, if it is possible, you please hold the casting or hang the casting, strike it with a mallet. Strike it with a mallet. Mallet means a hammer made by wood. By hearing the ringing sound, we can tell it whether any internal crack or any subsurface defect is present or not, but we cannot locate the position. For the locating the particular position, whether any blowholes or subsurface crack is there, there is another authentic technique, that is known as X-ray technique or gamma technique. Mainly we use X-ray technique, go for X-ray. X-ray will give us detailing, whether any penetration less is there, whether subsurface crack is there, whether blowholes is there. So, X-ray technique is another technique through which we can detect whether the casting is sound or not. And the last one is known as ultrasonic technique. With the application of ultrasonic method, we can detect the different type of defect which is available in any casting, whether it is sound or not. So, there are some techniques which I have uttered one by one. First, visual inspection, pressure test, magnetic particle inspection, dye penetration inspection, radiographic examination, ultrasonic inspection. It depends upon depending upon the size of the material, what type of test. Most authentic test is radiographic test and ultrasonic inspection, through which we can detect about any kind of defect in the casting. After this, in case of making a pattern, how there is another, you please notice one thing, that no sharp corner is present into the casting, rather some filleting is done. If you produce sharp corner in the pattern, so pattern making is also a technique. The man who is got expertise on pattern making, he knows it, no sharp corner should be provided in the, because sharp corners, it is act as a stress raiser. So, there are so many tidbits are there when we will do it by our own hand, as well as with the help of different tools in our workshop. When we will meet, we should discuss different types of problems, we will solve here a problem. And after preparation of the mold, with the help of the pattern, keeping in mind that this should be our target, it should be defect free casting. So, there are different techniques depending upon the condition, depending upon the material, depending upon the material of the mold and the metal which you are pouring into this. So, there are different techniques through which you can produce sound casting. Thank you. This is our turn, how we should make the mold. with the help of single piece pattern. Today we will use single piece pattern. One is known as reversing gear handle of a lathe. At first we should make this, with the help of this pattern we should make the mold. After that, no other pattern is used for reversing gear handle, because with this help of this pattern we can change the rotation of the lathe in case of, we can change the rotation of a lathe. After that we should see the how to make the core with the help of the green sand. We should not take the help of this dry sand core. So, core can be divided by the two parts. This is known as dry sand core, and if we go for the making this pattern we will use green sand core, which is economic. So, these two patterns, with the help of these two patterns we should make some mold just after 2 to 3 minutes. You please notice how molds are made. It may be single piece. Suppose if we want to make it this pattern, it is 2 piece. If it is possible, we can go for the 3 piece or multi piece pattern. Thank you. Now our beloved member in this molding shop, Mr. David, will demonstrate with the help of different tools, pattern with drag box and cope, how to make a mold with the help of the green sand. As it is green sand, it is known as the green sand mold. David, you please. Now this is single piece pattern. Name of this pattern, basically reversing gear handle of a lathe. The pattern material is wood, and these 4 parts which I have already told, that is core print, added projection in the pattern. Now we should notice our beloved member Mr. David, how he keeps this pattern, whether in this way or in this way. Now from this point, you please keep your eyes properly about the proper function of this pattern, how he develops the mold with the help of this pattern. Basically it is single piece pattern. David, you please do it.
Okay. First of all, this is a cope.
Drag.
This is a cope. With the help of this cope, we are going to make this entire thing. So the place which is ready, we should make it ready as per as this size or a bit greater than this, which will help you all to finish the job in a well manner. So this is the place where we are going to start this operation. Catch this pattern, place it in the green sand. These are basically known as pegs. Catch a peg, place it in the pattern and try to hit it simultaneously till the entire pattern penetrates in the green sand. Once this pattern is penetrated in the green sand, you will need this. This is basically known as rammer, as it has been already explained to you all. With the help of this rammer, we should ram the entire portion which will be towards the pattern. This is the pattern, so we need to catch it in a horizontal way and we need to ram it towards the pattern. While ramming towards the pattern makes each and every sand particle enter the core and the hollow places of the pattern. After ramming towards the pattern, you need to take some sand, cover the entire pattern. After covering the entire pattern, you need to just tap it with your hand. Now after tapping, this is your cleaner, your planer. With the help of this planer, we need to find the job and we need to make a plain surface on it so that we can place the cope on this. We are basically cutting the excess sand which is there on this part. Now, as you can see that the entire thing has become plain. So this is the handle. This is basically a thinner section. So what we are going to do, we are just going to cut the handle in an inclined way. This should be around 45 to 60 degree incline. After cutting the handle, what we are going to do, we are just going to place this cope on this. Placing the cope, this is basically a normal sand. Okay, we need to sprinkle the sand on this area, but before that, these have already been explained that this is a screw pins, the runner and the riser. The one should be placed at the center of the job and one should be placed at the outer area. After completing this, we need to sprinkle the sand over here. This is a parting sand which divides the cope and the drag from each other. Now, this is a plain sand. We are taking this and we are filling the entire area again. Now, we have already done a ramming towards the pattern. Now, this is the wall. The wall, we will now ram towards the wall of this scope box. Take your rammer, start ramming towards the wall. And we need to complete a circle and then we are going to the center of this job. First we are finishing the outer area. After that, as it comes in the center, we are coming back to we are placing this rammer in a 90-degree pattern. Again, once it is completed, you can see that there is a gap again. Again, we need to fill it with sand. Once it is filled again start ramming. Now again with the help of your planer, just try to plane this thing. Once the planing process is done, this is a cleaner. With the help of the cleaner, we need to cut a funnel shape over here so that the molten metal can enter and exit easily from from this cavity. Slightly twist it, pull it out. As you can see that this is a total cone shape over here. Now these are pegs. We are using 4 pegs in 4 different directions. Either you can hit it here or here. after this, your same parting sand, we are just giving a mark over here so that we can remember that this is the place. This is your venting rod. Leave the venting rod in the entire hole because both are of same size. Take the entire size of the hole. 1/3 you need to do a venting over here so that hot air and gas will come out easily from this. So this is completed. I mean, need to lift it. You're lifting it. To this, either on this side or this side, whichever side is comfortable for the workers. Then you will need to lift this up straight and you will need to place it in a reverse direction. So this is the cope and the drag divided into two. This is water. We are just pouring water at the side edge of this job. This is a lifter and a rammer. With this, we just need to penetrate this so that we can pull out the pattern and get the mold cavity. Need to tap it from all the four sides. So while pulling this out, you will get a mold cavity out here, okay? Now after taking out the pattern from there, you can see a mold cavity has come up. Now we need to cut the gate so that we can pour the metal from this scope so that it enters the drag portion. So we need to take this cleaner again and we need to cut a gate over here. So this is your gate which has been cut, and these are the two holes which is one riser and one is runner. So after completing the entire job, what we need to do, we need to catch this cope again and we need to place it as it was. So after completing the entire thing, the molten metal is brought and it is poured over here where we cut the gate. So once the cavity is totally filled up with the molten metal, the extra metal automatically runs from the riser so that we come to know that the entire cavity has been filled up and we stop pouring the metal. So after completing the process, we give a time like 7 to 8 hours to cool the metal. Once the metal is cooled, we just take it out from the mold cavity and we get one of this solid structure. This is basically made of aluminum which has been already poured and made. So after completing the entire thing, we will get the entire structure. So this was the riser part which we need to cut it and we need to make a total finish over here. As you can see that this is the pattern, the wood pattern, and finally we got a aluminum pattern over here which has been totally come up. And as sir has already explained out that there is a machining allowance regarding this foundry process. So you can see that there are some burrs and some ups and downs over here. So this will go to the machining and it will become a total gear after completing the entire machining process. Okay, you all have already seen the first job which was the reversing gear handle. Now this is a plumber block cap. In this we are going to make a slightly different pattern over here, which you all are going to make a green sand core over here. So the entire process is same like the first job, but only in this we are going to make a green sand core so that you all can look. First of all, this is the place where we are going to start the job over here. we need to plane the entire surface and make this totally hard enough. Once this drag is hard, take the pattern, place it over here. Again, with the help of any wood piece and this rammer, we are going to just hit it slightly so that this penetrate in the drag. Once it has been penetrated from all the sides, with the help of your cleaner, we are just scratching this part and making this part a bit rough so that we can make a green sand core over here. After scratching this thing, we are taking again the green sand and we need to fill this entire gap. As you can see that this gap has been already filled. Take some extra sand and place it over here so that you can make a core over here. Tap it with your hand and make this core hard enough so that you can do your rest of the operation on this. Once both the side has been completed, again with the help of your cleaner, need to cut the extra sands. Now as you can see that this core has been completely on the line of this pattern. You can see a pattern over here, the half pattern over here. Now, with the help of any of your wood or any wood piece, just need to tap this pattern and pull this thing out. Now after completing this, you can see that 3 parts has been come out, 1, 2 and 3. The center part is a bit plain and it is in a smaller size. We need to make a total long parallel as this so that this can fit easily and we can complete the rest of the operation. Now, as you can see that there a core has been completed as you are working on a green sand. So this is known as green sand core, which will help us to complete the entire operation of this plumber block cap. After completing the entire thing, we are placing this pattern once again. Need to plane out the area. This is your cope. We are placing a cope again. Your runner and riser. This is your runner what we are placing out here. Your green sand. We are putting the parting sand out here. And now, as if your first job, we need to cover the entire thing over here, this entire sand over here. Now with the help of the rammer, as you all have done, we are ramming it towards the wall. Riser ending. Again your venting rod, 1/3. your pegs. No, finish. As of first job, you'll have done the marking. This is the marking, and the entire process will be as the first job. You'll need to lift this and turn it around, place it in a plane shape, and you will be getting the mold again. Lift it. This will come or it will break, I don't know. It is coming or it is breaking. It is coming. You can see here, the core is over here and your pattern has been shifted to the cope. Now we need to remove the pattern from there. The process will be same. Take some water, pour it in the outer line. Your rammer. Tap this pattern, make it loose. Remove your pattern and you will get the mold cavity of the second job, which is the plumber block cap.